Hello students, welcome back to our class. We were dealing with the topic phenols. So this is from your alcohol, phenols and ethers lesson only. We have covered already two parts of this topic where we have discussed the important preparations and chemical properties. Now we'll move ahead with some more chemical properties, that is Kolbe's reaction. So it's a naming reaction, an important reaction whenever we are discussing about phenols. So what happens in Kolbe's reaction? Phenol first forms phenoxide ion by reacting with NaOH. NaOH being strong results in the formation of its salt, because phenols are considered acidic in nature. We have discussed this, right? O has minus charge and Na carries plus charge here. Now what happens? This phenol reacts with carbon dioxide and then subsequent hydrolysis is also performed. Subsequent hydrolysis is performed in order to remove this Na plus charge, and CO2 is being reacted to form the desired product. So desired product which you get is this 2-hydroxy benzoic acid, and it is known as commonly salicylic acid. Salicylic acid is the starting material for the aspirin formation. That also we know that, which is an important analgesic. So this is Kolbe's reaction. Its mechanism is important. So let's see that mechanism as well. So in mechanism, phenol first reacts with, suppose now KOH or NaOH both can be taken, right? So we know OH carries minus charge here, K carries plus charge here, and here this H will carry plus charge, O will carry minus charge. So interchange the charges and join them together. So this will result in the formation of the salt O minus K plus. Now this sodium phenoxide is being attacked by carbon dioxide. Okay. So here we know oxygen is more electronegative, right? Carbon is electropositive in terms of electronegativity. So this oxygen takes the electrons towards itself, carbon gets the plus charge, oxygen gets minus charge. Here we have this plus minus, so this plus charge is being attracted by this bond pair of electron, and this minus charge comes down, and it results in the formation of this type of structure. Okay. So what happens then? This K is being removed and this H is taken up by this O. This goes up and this bond comes down. This is 1,2 shift, okay, right, at 1 as second carbon. So the next structure which you see is this, right? So these steps are easy to understand. Plus H plus, right? An acidic medium is introduced. in order to complete the structure. So that's how you get your orthohydroxybenzoic acid, that is salicylic acids. So first sodium phenoxide is formed, then carbon dioxide molecule is being attacked, is added in this manner, 1,2 shift takes place of your electrons and then results in the formation of the salicylic acid. So this is the mechanism of this reaction. After that we will discuss about next chemical reaction, again a naming reaction, which is your Riemann-Tiemann reaction. In Riemann-Tiemann, what happens? This first will result in the formation of sodium phenoxide, and the sodium phenoxide is being reacted with the chloroform in the presence of any alkali. Let's say potassium hydroxide. So then it forms your ortho and para substituted salicylaldehyde. Okay, orthohydroxybenzaldehyde, para-hydroxybenzaldehyde is IUPAC name, and then 2-hydroxybenzaldehyde, or you can also call it 4-hydroxybenzaldehyde. Commonly it is known as this. Its mechanism is also important, where this sodium phenoxide reacts with chloroform and alkali and subsequently reduced to form this compounds, right? So let's see the mechanism part now. So we will see the mechanism of ortho product formation and para formation both. So in the first step, what happens? We have taken chloroform, right? CHCl3. This is being attacked by the alkali being used, right? And will form a molecule of water and this CCl3 minus. Okay. When you expand this CCl3 structure, what happens? One chlorine is being removed completely and it results in the formation of a structure in this manner. At one orbital of carbon will be completely vacant and one will be having these lone pairs. Lone pair means 2 electrons. Now this is our attacking reagent. So this is potassium phenoxide is formed and is being attacked by this electrophilic attacking reagent. It is deficient in electrons, right? That is why electrophile. So what happens that these electrons of oxygen will come down and these electrons will be given to this, and in this manner it will get attached on the carbon. K is subsequently removed. Okay, and we know here is one H is also there. and it will attach in this manner, right? Now what will happen that this H is taken by this O and this bond will come down this side. See carefully that how the bond movement takes place. So it will result in the formation of CCl2 here and OH this side. Now it will react with 2 OH minus ions from the alkali molecule. To form this unstable structure, and then subsequently what happens that this H is also taken up by this carbon. So this will add up as CH, OH whole twice and O minus will be left. And then in the next step what happens? It is an unstable. So it is removed in this manner. A molecule of water is removed. So we are left with this CHO आ गया यहाँ पर O minus. Okay. So then you will acidify it to complete the structure and you get your orthohydroxy benzaldehydes, that is orthosalsaldehyde. So this is the mechanism for the formation of your ortho product. Now we'll see the formation of your para product. So till here it is same and it will change from this part. Okay, so we'll start with that. So this is the structure we got initially, right? So what happens that shift takes place in this manner, that minus lone pair will come on to form the bond pair and this bond pair will come this side and this bond pair will come on this carbon, which will attract this structure formed, right? So the addition product which you get is in this manner. Like this. Okay, K will be removed simultaneously. Okay, so what happens that this H will be taken up by this O and this bond will come down this side and this bond will come down this side, which will result in the formation of your next structure in this manner. This as this structure, a bond introduced here, a bond introduced here, this was same and OH in this manner, and then it reacts with the 2 molecules of OH minus in the next step, where it simultaneously extracts the electron from the OH part as well. So it forms an O minus, and you saw that earlier also in ortho product formation that this is an unstable structure, so it will result in the release of a water molecule So this is, now you can see the formation of para product. So the next step is that you will react with introduced proton to form your para-hydroxy benzaldehyde. So this is the mechanism of Riemann-Tiemann reaction when you are forming para product. Okay. So these mechanisms are important here. So do remember this. Now we'll move on to next part. So the next reaction is when phenol is reacting with zinc. So this is very common example when you have studied about aromatic compounds formation, right? Benzene formation. So phenol is actually being reduced using zinc. Or sometimes it is also written as zinc dust. Zinc powder is being used. So it results in the formation of benzene, and zinc is removed this O as zinc oxide. Now we'll see the next reaction, oxidation. So when phenol is undergoing oxidation using sodium dichromate, it is causing oxidation actually. So it results in the formation of parabenzoquinone. So after that, all the important points from this phenol is being completed. Now we'll practice some important questions from this topic. So two questions we have, that when this metamethyl phenol is reacting with dilute HNO3. Okay, so this is a bond-like notation form given, and this is an alkyl group and one written in this manner, so it represents CH3 group. Do remember this. So it is reacting with dilute HNO3, so we have to form ortho-para products, right? But the twist is that when we are forming the ortho product, what you need to remember is that this is placed on first position and there we have methyl group. You cannot attach the electrophile NO2 plus on this position. Why? Because it will result in steric hindrance and such type of molecules will become unstable. So that is why ortho product will be shown this side. Para product will remain same because para position itself is one only here, right? So in this manner you will form your respective products and answer for this question. Now let's see this question where phenol is reacting with your ethanoyl chloride. Okay, it's an acetylating agent, acetyl group will be introduced. So we know bond will be broken from this side and from this side. So what will be our A product? Minus HCl will be removed, rest will be joined together. So this will result in the formation of an ester C6H5COOCH3, right? So this is our answer, methyl benzoate, right? Now this methyl benzoate is undergoing nitration, HNO3 and H2SO4. So in hint it is given that the B product is the major product. So obviously it is reacting with dilute HNO3, right? And the B product, the major form will be this. The first carbon functional group attached to it will remain same, and the major product NO2 electrophile will be attached this side, because in nitration the electrophile NO2 plus is given. So this is our answer for these questions in this manner. So with this we will wind up our episode here, where we have discussed important reactions of phenols. We have covered this phenol in different parts, so do revise all those parts for the proper understanding of this topic. We'll meet again with another interesting topic. Thank you so much.